Okay, the following video will be the step-by-step directions on how to assemble part 8A and 8B, which will become part 8C. So first thing I'm going to do is go to my Schoology page, and on your home page, you're going to look under the beginning SolidWorks. And I'm going to expand this folder out, and going towards the bottom, I'm looking for acc8c.pdf. Go ahead and left-click on that. And for my sake, I'm going to go ahead and download this by hitting the download button here so I can make this full screen. So I'm going to hit download, open this up in Adobe Acrobat, and say OK. Expand it out so it's full screen. And let's talk about what we got going on here. So previously in class, we've already created part 8A and part 8B before the Thanksgiving break. Today, what I want to do is take those two parts and put them together in what's called an assembly. In addition to putting those together, we're also going to learn how to bring in some screws, create basically what we call an assembly, fully put together, and one is called exploded that shows us how it goes together, in addition to adding in what's called now a bill of materials and adding in our balloons. So I'm going to go ahead and start by getting my SolidWorks up and running and getting my assembly up and ready to go. Okay, now the big thing with this one, there's not a lot to this. The biggest part of this is just putting it together. We have no dimensions to add. We just have a couple titles to add in here. And we just got to learn how to add these little pieces and elements in that are new. I do also want to make sure that we talk about how we get the page number to 8C of 8. That is going to be imperative for this. Going into SolidWorks, I'm going to go ahead and start with a file new. Now here's the deal. In our case, SolidWorks Templates does not have a starting point for assemblies. We have nothing in there. So what I'm going to do is I'm going to use one of the other tabs that are located at the top here. In my case, I only have one more, and I'm going to pick the one called Tutorial. Now, what we've been working on, we started off the year with doing our flat layouts on the draw. Okay, and we've created drawings. All right, and we've been doing that quite a bit. We've also been lately creating a lot of parts. The next thing we're going to do is start doing what's called an assembly. And that's where we take parts and put them together using what are called mates. So what I want to do is I want to highlight this assembly. I'm not worrying about the units right now because all we're trying to do is put this thing together. I hit the word assemb and I'm going to hit the word OK. Now, in this case, it's going to automatically open up. It's looking for the beginning of the assembly. And what it's doing here is it's basically asking you, what part do you want to start with? Well, if I look at this drawing back here again, the most logical piece to bring in first will be 8A, the base. So I'm going to come back into SolidWorks, and what it's asking for, it's basically saying, where is your 8A? Well, I'm going to go right here to ACC 8A. I found one for my 2A. Highlight it, and say open. Now what it's going to do is basically follow my cursor. So I'm just going to kind of plant my cursor in the middle of the screen and left click. And now what you've got is you've got this base piece is stuck in the middle of the screen. Now what I need to do is I need to bring in the secondary piece, which is 8B. Now you'll notice also that we started assembly, a new tab has been created in our toolbar. It's called assembly. So we got assembly, we've got our layout, which we've done before, which is all our sketching tools. In this case, we got our sketch tools, layout tools, evaluate tools. Okay. Under assembly, if you want to add in more components or add in more pieces, you click on the one right here called insert components. You left click, and again, it goes right back into opening up and having you search for what part you want to bring in. I would like to bring in an ACC 8B for period 2A. And say open. And now the same thing's happening. It's following my cursor. Now I'm going to try and go ahead and put this over here to the right. It doesn't make sense to put it over here since in the picture it shows it connected to the right hand side over here. So I'm going to drop it out here in space and left click. Now before I bring my screws in, I would like to get these two pieces put together. And the way we're going to do that is under the assembly tab, we're going to use a tool called mates. And the mate tool is very similar to what we did in our sketching. The mate tool is similar in the aspect when we added in our relationships to get things to line up or attach to each other. It's the same thing with the mate tool. The same words that we used in the relationships are also going to be used in our mate. So to basically get this to activate, I'm just going to left click on the word mate. It looks like a paper clip up here in the left-hand corner. Now, as you can see, we have choices: coincident, parallel, perpendicular, tangent, concentric, same ones we've used before, okay? Now, when I'm doing an assembly, the way I'll try to be or think about it is as a builder. And what I mean by builder is I am basically putting my mind frame in the sorts where I was just handed these two parts and now I have to logically put them together. In most cases, if I'm looking at this, my first instinct would be to line up the holes where the screws have got to go in. Now to do that, I'm going to use my middle mouse button a lot in this process. I'm going to push it down and rotate. And what I want to do is I want to take this hole here on the left side of 8B and match it up to the hole on the left side of 8A. Well, to do that, under my mate tool here, all I need to do is say, okay, I want the inside of this hole to line up with the inside of this hole. And what SOLIDWORKS is going to do is think a little bit for you. It's saying, okay, you want a circle and another circle aligned concentrically, which means they're sharing the same center. You'll notice that SOLIDWORKS moved the part in. Well, if I hit my check mark, what you'll notice is really all it did was line this hole up. I can spin around that hole pretty freely. All right, so I don't have this thing quite where it's supposed to be. This is supposed to be locked in here and not move. Well, in that case, that tells me I probably should line up this right side hole with this left hole over here. You'll notice that SOLIDWORKS had the 8B tip up. Well, if I hit my green check mark, now I can see what's going on. If I push this through a little bit, you can see now the holes are lined up to each other. Now, my final step is I need to get this face here and this back face here to touch each other. So with my mate tool still active, I'm going to click on this right side face of part A, rotate around with the middle mouse button push down, and hit the back face of B. And you'll see that the two have basically glued themselves together with what's called a coincident mate. Now at this point, I can hit my green check mark and close out of my mate tool. Hit my space bar and do an isometric. So right now I have my two parts assembled. The next step I need to do is I actually need to come in and add in 2 screws. Now to do this, I've got to know what type of screws to look at. So one of the things you've got to start learning to reference is this box down here in the right corner. This is called a bill of materials, and you will see this on every assembly we do. This is basically a recipe card. What it's telling you is how this part was built, how many pieces for each part, and what materials or any kind of specific description are needed inside here. The one I'm looking for, and I know there's a mistake right here, this should be a number 3. I don't know why it went to a question mark, but it should be number 3. If I blow up on that box and look at it, number 3 right here is pointing to 2 screws. That is this thing right here. And what this is showing me is that these screws are B18.67M. I don't expect you to know what that is, but I do want you to know the size of the screw. The size of the screw has to match the hole, and the size of the screw is going to be an M10 by 1.5. The length of the screw will be 35. Okay, the type of screw we're going to be using is what's called a type 1 cross recess. A cross recess, for those that know anything about screws, we call a Phillips head. That's this little symbol here. That's these over here. That's a cross. Okay, but the type of screw, and it comes down to this right here, FHMS. What this stands for is a flat head machine screw. So when we go for our screws and we go to the toolbox, we're looking for a machine screw that has a flat head. Flat head is what you see right here. They're perfectly flat. So going back into SOLIDWORKS, I need to get my toolbox to open up. Well, if you look to the right side of your screen, you're going to notice there's a little pop-out over here. In that pop-out, you see a house for resources, a stack of books for design library, a folder for the file explorer, basically a view palette, which allows you to change views of what you're looking at on the screen. You can do all your appearances, etc., etc. Okay? I would like you to click on the box or the stack of books. Left click there. And what you're going to notice under Design Library, there's one called Toolbox. Now, the first time you click on it, it's going to ask you, do you want to load in or add in now? Click the add in now. It should be sitting right here in this part of the screen. When you click in add in now, what you're going to see is a bunch of folders appear. Now, if you recall from when we were doing our whole wizard, one of the things we had to enter or put into the whole wizard was the standard. And you remember right now we've been only using ANSI inch and ANSI metric. But below those, we saw ones like AS. Well, that is Australia. BSI for British. CISC for Canadian. DIN for German. Okay, GB for, I believe, China. Hopefully I know my flags. Okay, you see Japan, you see the military, all kinds of stuff. What I'm trying to point out here is that our toolbox ties directly into the whole wizard. So that we have to use those two synonymously. So when I'm using the whole wizard and I need to put some screws in, they are going to match each other up. Okay, now, with that said, the first thing I got to realize is what units I drew these two parts in. And if you recall from doing those two parts, we did both of them in ANSI metric. So what I'm going to do is double click on this ANSI metric folder. And now you'll notice we have subsequent folders underneath. We have bearings, bolts and screws, nuts, O-rings, power transmission, which is basically gearing. Okay, and then we have, in this case, we have retaining, what I call snap rings. If you've ever built something, you have to use a snap ring to retain it. We have washers, okay? Now, logically, you should be looking and saying, okay, I need 2 screws. So the folder we should be double-clicking on is bolts and screws. I double-click, and you're going to notice I have a whole slew of more types of screws. Hex head, machine screws, countersunk, self-tapping screws, set screws, socket head screws, and studs. Now, if you recall, I said this is an FHMS screw, flathead machine screw. Now, your natural tendency would probably be thinking to take the machine screw right here. But you've also got to remember that these holes are countersunk. Okay, so when I'm actually in here, I'm looking for, a machine screw. I apologize, I'm clicking all over the place. A machine screw countersunk. I'm going to double click that folder. And what you're going to see is I have 2 choices within the folder. Choice number 1 is a flathead screw. Choice number 2 is an oval head screw. All right, and if you recall, I said FH, which is flat head. So I'm going to use this screw to the left as my screw that's going to go into these holes. Now, to get those screws to come out, I'm going to left click on this flathead screw, drag it out onto my screen, and let go of my left mouse button. Now, when it comes in, the default is going to probably put it at its smallest piece that it can be, which is an M2. Okay, if you look to your left, here is our document manager, or configure component, where we can configure this. What I want to do is now change the size of this. Now, looking back at this note, I said the size was an M10 by 1.5. So I'm going to go over here to SOLIDWORKS and change this from M2 to an M10. And you'll notice suddenly it got a lot bigger. Okay, the length. In this case, that was the new number I showed you at the end. The length will be 35. That is how long the screw will be. So I'll come back over here to SOLIDWORKS, drop the length down to 35. The drive type. If you look, we have 2 choices, either cross or slotted. If you read that box carefully, it told us to be cross, and cross is usually the default. It's a better screw to work with. All right, last but not least is thread display. Now, if you look at this note, it actually tells us what type of thread we're using, and it's right here with this letter C. There are 3 letters that will be attached to this, either an N for no threading, C for cosmetic threading, or an S for schematic. What does that mean? Well, if you look right now, this is no threading. It's called simplified. If I drop it down to cosmetic, it will look like threads, but it's only a decal. Now, when you do this, this is for cosmetic. That is the letter C, which is what we're going to keep. The last one you can work with is schematic. It looks cool because it looks like the real thing. The downside, though, is this takes a lot of processing power for the computer to make this happen. If I'm only doing a few parts and I'm trying to show off and make it look really cool, this is the one I choose. But in most cases, since our assemblies are a little bit larger, and I don't want the computer to bog down trying to process all these threads, I prefer to use cosmetic. The computer sees this nothing as a simplified screw with a decal. It's nothing more than like a sticker, okay? Minimal memory, all right? Now, I have my screw set up exactly the way I want. It's the right size and the right length. It's got a cosmetic thread on there. Now at this point, I'm going to go to the green check mark and click. And what you're going to notice right away is I have more screws coming up. So I'm going to drop a second one right next to the first one. And then I notice I'm still got more screws I can keep clicking. But in this case, I only need 2. So what I'm going to do at this point is hit my escape key to turn off the implementation of screws. Now, I need to mate these screws into this hole, or these holes, okay? However, this one here is backwards. I need it to look like this one, which means the threads are pointing towards the hole. So what I'm going to do is under the Assembly tab, right in the middle where it says Move Component, I'm going to drop the arrow down and do a Rotate Component. And I just want to make sure it's a free drag. What that means is basically I can click on the part and drag it any way I want. So what I'm going to do is come out here with my cursor, left click my mouse button and hold. You see it turn blue. And I'm just going to rotate my mouse around until the screw looks like it's pointing in the right direction. This does not have to be perfect. Just as long as you have it pointed to the hole, you are okay. As soon as I'm done with my rotating, I'm going to hit the green arrow or green check mark and get out of it. Now, I need to mate these screws in. So I'm going to turn on my mate tool. Now again, it's the same process. I want you to think like the builder. I need to take the shaft of the screw and line it up with the inside of this hole. And what it's going to do is make it concentric. I'll hit my check mark. The downside though is all it did was line up the inside of the hole. I also want the back face of this screw to be flush with this right side face of 8B. That will be coincident. If I hit my check mark, I now have the screw right where I want it. It doesn't matter if it spins inside, that's okay. But it's flush with the surface that's in the hole, okay? I'm going to repeat that same procedure on the other side. I'm going to click the shaft of the screw and match it to the inside hole of the countersunk. Hit my check mark, and again, you'll notice all it did was line it up. In order to get it flush with the surface, I'm going to hit the back face of my screw and tell it to be flush with the right face of 8B. At this point, I hit my check mark. I'm going to go ahead and turn my mate tool off and hit my spacebar isometric. At this point, 8C is done. You have assembled your first assembly. Congratulations. But I need to save it first. So I'm going to go up here and do a File, Save As. And I'm going to save this in the same spot that I have all my 8A and 8B parts. I want everything to stay together. Don't move it to other areas. So keep them all in the same folder. I'm going to name this caps lock AZC 8C underscore my last name and hit enter. Let's say yes in this case. I want to replace it. Okay. So at this point, what I'd like you to do is go ahead and print your mass properties of this entire assembly. So again, to do mass properties, I'm going to go to Evaluate, Mass Properties, and now I'm looking at the total mass of this part with screws at 2,725.97 grams. At this point, go ahead and print this. Make sure it's printing to the L108 Tech Lab printer and say OK. As soon as you go and retrieve it and bring it back to your desk, go ahead and close out your mass properties. Now, looking at the problem here, we've got this view done. And if you look at the bigger picture here, we've got all 3 of these views done. So we really have 4 of our 5 views completed. However, I still need one view showing the thing blown apart, what we call exploded view. It is kind of like a set of directions on how to build it. Because if you look here, you can see pretty easily that, oh, okay, 8B lines up with the holes and will butt into here, and then your screws will go in the hole. We have to create this. And the way we're going to do that is going back into SOLIDWORKS. Under the Assembly tab, over to the far right, there is a button called Exploded View. Now don't panic. When you click on this, nothing's going to happen. Okay, we have to tell it what we want it to do. So I'm going to left click to turn it on. And then basically over here to the left, I get these choices. Okay, it wants to know the exploded step number 1. What's the first thing I want to do? Now again, I want you to think like the builder. I'm asking you now to disassemble this. What would be your first thought? In most cases, you would be thinking, I need a screwdriver and I need to take the screws out. So in this case, what I'm going to do is left click on each of the screws. Okay, and you'll notice that the screws have turned blue. Okay, in addition, you're going to see what's called a triad. Now, what the triad does or shows us is that we can pull these screws out in the X direction, the Z direction, or in the Y direction. Now, in our case, I want to pull it out in the X direction. To do that, I'm just going to go to this arrow right here when it turns blue and left click. Keep holding your left mouse button and pull the screws out. Now I'm going to eyeball these to about 120 millimeters, okay? It does not have to be perfect. Everyone's will be slightly different than mine, and that is okay. I'm going to let go of my mouse button. Now it's still active. It's waiting for me. Do you want to move it more? Do you want to move it in? Do you want to rotate them, twist them? What do you want to do? To tell it I'm done, you actually have to come over here to the left, and there's a button right below, right here, that says done. Left click on it. Now we're still in the explode tool. So what I want to do next is click on part B, and it turns blue. This is going to be explode step 2, as you can see over here to the left. Again, I have a triad. I can pull in the X, the Y, or the Z. Like the screws, I'm going to left click and hold on the X and pull this to where it's about halfway. Now, at this point, that looks pretty good. Okay, if, for instance, you want to go ahead, and I'm going to hit, in this case, say done. If you wanted to go ahead, and let's say you had to move this more, and I'm going to adjust my view real quick to isometric so you can see this. I want to move this one out a little bit more, so B. Well, if you look here in this white box, exploded step 1 was the screws. Exploded step 2 was the blue piece. When I click on that exploded step 2, I get that arrowhead again that I can pull and adjust. So I'll pull it out a little bit further and call that good and hit done. I can do that with the screws if I need to. I can adjust them in or out as necessary. Okay, in this case, I like where they're at. I think they're good, so I'm going to hit done. And then to finalize this, I'm going to hit my green check mark. Now, in order to save this, I don't have to save this as a new file. All I'm going to do is do a control save, because what's going to happen is under one file name, we have both an assembled view and an exploded view under the same file. Okay, so at this point, we have all of our views are ready to be created. So now it's just a matter of assembling the drawing. So this is going to be on the metric border, and this is a B-size paper. So we're going to use a GHS B metric to complete this. Going back into my SOLIDWORKS, I'm going to do a File New, go back to my SOLIDWORKS Templates tab, and hit the GHSB metric folder, or file, excuse me, and say OK. Now, I see my ACC 8C is already in there, so I'm going to hit the blue arrow to go to next. Now, what I want to do is I'm going to bring this in. Now, you got to be careful, because if you look at this, there's a new button right here that we have not seen before, because we've only been doing parts. When we do assemblies, it will give you this choice of showing an exploded or model break state. Right now, I don't want this to show an exploded. I want it to show as a solid piece. I'm going to uncheck that box. Now, the rest of the setup is just like all the drawings that we've been working on for the last 7 or 8 weeks. Okay, I'm going to hit the front view as my start, preview, and instead of doing hidden lines visible, we are going to do it with color. So I'm going to do it with a blue box. The scale for this part will be at 1 to 2, so we'll keep it right there. And then all I'm going to do is come in here and I'm going to drop my first view in the left corner, pull up and draw it above, and I'm going to pull the right view kind of tight, and then isometric up into the upper corner. I'm going to hit escape. Now, this view up here, I'm going to grab and bring it down here towards the lower right. Okay, so if you're looking at this drawing now, it looks very similar to this drawing here. There's my 3 views and my isometric assembled view in the lower right corner. However, I am missing the view up here. I need to add that in. So to add that view in, I have to go back over here to the View Layout tab in the upper left-hand corner. And you're going to have to start getting used to this because I'm going to ask you to put multiple drawings or pieces and parts on one drawing. The way to access those parts is to go back to View Layout, click the word Model View. ACC is still there, so I'm going to hit the next arrow. But this time, I want to show it in the exploded state. Okay, so I want this box checked on. But the only view I want to bring in is the isometric. That's it, nothing else. Do not do a front, top, right side of your exploded, just an isometric. At this point, I'm just going to kind of bring it out here. Oh, and add color, sorry. Add my color. At this point, I'm just going to kind of drag this out to the upper right corner and left click. And at this point, all my views are on the paper. However, I want to make sure that I get rid of all these black lines, just like we did on our previous drawings. So again, if you're looking at this view here versus here, we are very much similar now. Okay, we've got our three views, we've got our assembled, we have our exploded. So really what's left is to add in our titles and to put our bill of materials in. I'm going to start with the easy stuff first. I'm going to highlight this title right here and do a Control-C for copy. I'm going to go over here to SOLIDWORKS, to the drawing, and I'm going to go to my annotation toolbar and turn on my note tool. Now, somewhere below 8C exploded, I'm going to left click, and then I'm going to do a Control-V. I'm going to make sure this is centered. I want to make sure that the bottom is not bold, but the top is bold and underlined. Now in here, this is where you're going to actually put your mass. Whatever it was I think it was 2725.94, I think was the number. Okay, and at that point, this title for part number 1 is done. Going back to my isometric, I'm going to highlight this other title below and do a Control-C. Go back over to my SOLIDWORKS drawing. Take the note, put it below this part right here, and do a Control-V. Make sure that it is centered and that it is underlined. All right, so there takes care of my 2 titles. So the next thing I need to do is I now need to go through this drawing and I need to add in this box below. This is called a bill of material. It is a table. And if you look in your annotation toolbar, you'll notice at the far right, you have what's called tables. If you drop the arrow down, you're going to see one specifically called bill of materials. In all of our assemblies, this is the only table we will use. Do not ever use a general table or a whole table because it will come out wrong and I will know right away because it looks very distinctly different than a bill of materials. So we want to click our bill of materials. Now the biggest thing with this, it's real straightforward. If you look to the left, there's only one thing you have to click on before hitting the check mark, and that is where it says parts only. Make sure it is checked on. Once you have that checked on, hit your check mark and drag below, and you'll see a table following your cursor. Now I'm going to drop it right there. I'm not going to panic that it's a little big, because what I'm going to do right now is I'm going to go in and I'm just going to make some fine adjustments. I'm going to drag this. This is nothing more than a spreadsheet. So if you've worked with Google Sheets or worked with Excel, it's exactly the same process. I'm just going to grab this little bar and pull a little bit wider, and then I'm going to go ahead and move some of this stuff up to make the box a little bit smaller. Maybe break this in a little bit tighter. That looks good. And then at this point, maybe take and bring this in a little bit tighter here. Now, mine came in with a wording, okay? Yours will not, all right? The reason mine came with a wording is I've already done this problem multiple times. Now, what you're going to need to do is to get the wording in here, you're going to need to double-click inside here, and you're going to get a pop-up. When it pops up, I want you to hit the word Keep Link. Okay, I want you to type in the following and make sure they're in all caps. Anything not capitalized will be marked wrong, except for this note right here, since this is part of the way the screws came in. I want you to type in base, oops, I already broke my own rule, base plate, space dash space, brass. Click away. Go to the second one and double click. Keep link, Same thing. We're going to have support bracket, space dash space, brass. Click outside. At this point, I'm going to go ahead and tighten this up a little bit more. And then to kind of move it, there's a little X in the corner. If you left click and hold, you can then drag your box to where you need it. And that looks good enough for me right there. Okay, that looks good. All right, so this is my bill of materials. Now again, let me explain what we have here. It's a recipe card. What it's telling me is that the first part I brought in, part number 1, was the ACC 8A, the base. The second part I brought in was ACCB, the support bracket on the side. And then the third part I brought in was the 2 screws. Okay, so basically it's telling me the recipe. In addition, it's telling me what the recipe or the parts are made of. In this case, it's called a base plate made of brass and a support bracket made of brass. And it's also telling me how many of those parts I have. I have 1 base, 1 support bracket, and 2 screws. Okay, now the last thing I have to add to this, I've got my table now, is add what are called balloons. So we have to identify where these parts or what these parts are. Now this is really important to understand. These balloons I'm about to add on match this table. Now this is something that's really imperative that you hear. Okay, so make sure your headphones are on and you're listening. Whatever your table comes up as, so if your numbers are different than mine, do not change them for any reason. Leave your numbers alone because those numbers are directly tied to your balloon. If you begin to mess with these numbers here, your balloons will not match your bill of materials. And for every balloon that does not match, it is a point deduction. So if we had 15 balloons on here and you change all your numbers so none of the balloons were to match these numbers in column 1, you would miss 15 points right off the bat. So in this case, leave them alone. Whatever this number is, all I do when I grade is compare this number to what is in the box. As long as these 2 match, you've got 100%. Now with that said, we are going to go ahead and add our balloons on. To do balloons, all I have to do is go right here on my annotation toolbar to this balloon tool. I'm going to left click. Now we're just going to use the simple default. These are circular. I want them 2 characters in size, and that's it. To add them on, all you do is put your cursor right on top of the part, left click 1 time, and then wherever you want to drag it to, when you place it right, just left click again. So there's part 1. I'm going to hit the top of this. That looks good there. Pull a little bit to my right, left click number 2. Now to get the double arrow, I'm going to click on 1 screw, pull here, but I'm not going to left click yet. I'm having to still move around, and then I'm going to hold my control key and pull a second arrow out, touching the second screw and left click. As soon as you have that done, let go of your control key, figure out where you want the 3, left click and be done. You'll notice my tool is still active, so I'm going to hit escape to turn it off. And at this point, my drawing is complete. The only thing left to do is to add in our title and our page number. So I'm going to start with a scale at 1 to 2. Drawn by your first initial and your last name. Put in today's date and the period for the class, in this case 4A. Checked by myself. Okay, please make sure we change that to my name. Okay, page number. Instead of 1, when it turns orange, double click and make it 8C. Click outside of it. Of 1, I want to highlight when that turns orange, double click, and that should be of 8. Last but not least is to place our title. The title for this one is going to be SOLIDWORKS Assembly Drawing ACC 8C. So I'm going to double click. I'm going to hit caps lock, SOLIDWORKS Assembly Drawing, space out of space, ACC 8C. I don't care if you use the number symbol or not. Okay, at this point, it looks good. File save, save all. If it asks you about your screws, in some cases I've had kids having struggles, it's asking them to save the screws somewhere, go ahead and add the screws into your CAD folder. Just go ahead and if it says save, go ahead and it'll ask you where, save them into your H drive under your CAD folder. That way it makes it really easy. I'm going to go ahead and hit save here and replace my old one. And then when you're ready, I'm going to go ahead and do a File, Print this to my 108 lab there and say OK. As soon as it's done printing, I'm going to go collect my paper. I'm going to staple that mass properties to the back of this and then fold it in half and turn it in. As soon as you turn it in, go ahead and begin working on the 4-bar assembly. Congratulations on getting your first assembly done and your first assembly drawing. Continue working hard onto the next one. If you have any questions, do not hesitate to ask.